Alright, in this question, you have a 3 kilogram mass that is tied to a rope and swung in a horizontal circle. So anytime you have that rope that is swinging into a circle, that rope is providing an inward centripetal acceleration and force towards the center. So once again, we know that centripetal is center seeking, and in this case it comes from the tension on the rope that is pulling whatever that is being swung towards the center in a circular motion. We're going to go and continue. If the velocity of the mass is 4 meters per second and the radius of the circle is 0.75 meters, what is the centripetal force and the centripetal acceleration of the mass? Our mass M is 3.0 kilograms. That's 3.0, that's a mass. The velocity is 4.0 meters per second, and the radius of the circle is 0.75 meters. What is the centripetal force? That is F with a small c for centripetal force, and the centripetal acceleration. Alright. You can really solve any of these. First, and I just made a mistake, that centripetal acceleration is A for acceleration and small c for centripetal, and that's what we're looking for. That's the question mark. You can solve either one of these first, and I'm actually going to solve the centripetal acceleration first, because from there all you have to do is multiply by the mass, and I'll let you know why after I solve for the centripetal acceleration. So in this case, the equation for centripetal acceleration is the velocity squared over the radius. And if we plug all of that information in, we get 4.0 meters per second divided by 0.75 meters. The 4 meters per second has to be squared. So you get 16 divided by 0.75. Your answer is actually 21.3 meters per second squared. So, of course, we can use the equation for the centripetal force for the second part is equal to mv squared over r. But if you can see, this v squared over r, we've already solved for. V squared over r is actually the centripetal acceleration. So all you have to do is go m times what we got for the centripetal acceleration, which is 21.3 meters per second squared. And what that makes is our mass is 3 kilograms. Our acceleration is 21.3 meters per second squared. And you get a 63.9 newtons as our final answer for our centripetal force. And please remember that that centripetal force and centripetal acceleration is pointed towards the center. There's no other way to have circular motion unless you have a force, a net force, that is directed towards the center.